I will first today talk a bit about the course and its organization and the way it works. And then I'm going to switch over to the actual content of the first week, which is Introduction to Debugging. So I'm going to share my screen now and hope this is all going to work. Let me see. Here we go. Who can share? Yes, that's so cool. Yes. Here we go. Okay. I want to share my screen. Okay, and now my panelists can also share their screen if they want to. And here we go. Wonderful. So you should now be able to see my screen on on automated debugging. And what we have here is cms.cispasalan.d/debug, which is the home for this course. This is where all of you have registered from the very beginning. And here we have our three faithful workers. Well, that's me. I'm the lecturer. We have Konstantin. Hello, Konstantin. Konstantin is, I'm not sure whether Konstantin.
Hello.
Konstantin, you say something. Hello, Konstantin. And we also have Johannes Lampel. Hello, Johannes.
Hi.
Hi. Who's also taking care of all the exercises and projects and everything. So I will go with you through the regulations briefly before we actually go to the actual content. So first, about this course. In this course, we'll be talking about a number of automated debugging techniques, that is, techniques that help you finding bugs quicker. We're typically starting from a program that fails, and then from there on, trying to figure out what is it that caused the program to fail, such that you can fix bugs faster. And we're even going into techniques that allow you to repair programs automatically. So all your work as programmer is done. You just repair. Whenever the program fails, it automatically gets repaired, and therefore there's actually no need to program things anymore. Well, that's a very vague approximation of how things will be, but that's where we're going. All of you already have managed to get into the Zoom webinar, so congratulations for that. And this is where we meet every Tuesday. But I'd like to point out that this is not your regular lecture where somebody like me will be there and presenting slides, but instead I will be going with you through material that you are supposed to process by yourself for the week that follows. So I'm having a couple of chapters. I'm writing a chapter every week on automated debugging, and these are self-contained. This is self-contained material, which in principle should work without me. And you're supposed to process that. And every Tuesday, we talk about the chapter that you just have read and answer any questions that you may have. And then I'm going to give out a chapter for the upcoming week. We'll come to that in a moment. In this course, the thing you have to do, well, besides reading things and listening attentively, of course, is projects. You will be building projects. In particular, you will be building your own automated debuggers. We're currently planning for 4 topics. Well, it will be precisely 4 topics. The first topic will be building an interactive debugger for Python, which means either a small command line debugger or a more complex JavaScript interfacing time travel debugger. This sounds enormous, but that's actually something that you can pretty easily do with the material that we provide. The second project will be something like automatically simplifying Python programs, that is, cutting out the bloat that does not contribute to a failure. And we do have a third project, which will hopefully be on automatically repairing Python programs. Fourth project is where you can do things at your leisure, and where you can do things at your leisure and build a tool of your own design. using the material and the techniques that we have discussed earlier. So this is where you will be completely free floating. And because this is a frequently answered question, there will be no exams indeed. Because it does not make very much sense to make a written exam on debugging techniques. This is like a written exam on swimming or something. If I ask you to swim, the way I find out whether you can swim or not is whether how you do in the water, and not by telling me that you first need to move your hands forward and then sideways and whatever. Well, maybe in swimming theory or something, but we are not doing debugging. Well, we're doing a bit of debugging theory here too, but mostly we're focusing on tool building, and it will be your tools that are being graded. So, which means that there will be only projects, no exams. So that's the good news. However, these projects will take a significant amounts of work, notably because because we not simply expect you to hand in a big steaming pile of code that somehow works, but we actually expect you to detail and explain every single step of your development in as text, coming as a Jupyter notebook, which we're going to discuss later. Okay, and speaking of, since many of you want to know when you actually be able to pass, each of these 4 projects will be graded with up to 30 points, 30, and you pass guaranteed if you total more than 60 points. So if you do the first and the second project with a maximum grade, then you can relax, you have passed. Otherwise, you'll have to continue. And if you have more than 100 points, you'll get the best possible grade, which is 1.0. So after you reach 100 points, yes, you're pretty much done because you cannot improve any further. But this also will not be. But this also will. But this also will not be that easy. The knowledge in this course will be applicable to all languages, including whatever C, C++, assembly, JavaScript, you name it. The reason why we're doing this in Python is that there are several things which are, in particular for debugging, which are so extremely simple in Python, and so horribly complicated in almost all other languages, that it actually is much more fun building these tools in Python and for Python, even if you account all the time it may actually take you to learn Python. So just to give you an example, if you want to, just to give you an example, if you want to build an interactive debugger for, well, like that, Rust, just because we can, right? Rust, well, taking out of my head, or Go, or whatever, okay? In particular for a compiled language, this will easily set you back, well, I would assume something between 2 and 6 months of work. And that's for professional programmers who know their stuff, okay? So we're talking 2 to 6 months. Whereas in Python, as you will see, building an interactive debugger is something that you are actually able in, well, make that 20 to 60 minutes. Okay, so you're about, I don't know, 1 minute versus 1 month. How much is that? Do the math yourselves. It's a factor of several hundred times. So, and this is why we're doing these things in Python, because in Python you can focus you can focus on the algorithms, and you can focus on the actual ways that these tools work, rather than on the specifics of having to implement all of this in a Rust/C+/whatsoever compiler. This is an amazing feature of Python, and it's absolutely, and even if you take into account that it may take you a couple of days to learn the basics, and actually a couple of hours is actually more appropriate, even if you take this into account, this will largely pay off, okay? So having said that, if you Once you learn how to do this for Python and in Python, you will find out that doing this for any other language takes so much more time, and you may be sticking to Python as your favorite language later on, just because it's so much easier to build debuggers in it. But the idea is that you can build first prototype things in Python, and then later, once you know how the principles work, port these to other, possibly more efficient, more elegant, whatever languages. Your mileage may vary on that. We have somebody saying life is short, use Python. Well, certainly true for teaching, because I don't want you to spend months on on figuring out how to include debugging information into a compiler of your choice. I want you to be much more. I want you to be much faster than that. So this is all about the course specifics. And as I said, you have made it into Zoom, and we're having a bit of projects. First project should be out in 2 weeks at the latest, possibly even already next week. And you will already have a chance to see what will be expected for you for the first project, namely this interactive debugger for Python. And also important, registration for this course is open until the 15th of November. So meaning that after the 15th of November, if you have registered for the course, you have to stick to it. And if you haven't registered for this course, you won't be able to still register for it. That's also that's something for you to put into your calendars. Okay, and this is already all the basic information I'm having about this course. And I'm happy to answer questions as they may arise in the chat window. And I'm asking for Konstantin and Johannes to forward some of these questions to me such that I can answer them right away.
Okay. So there is a question whether the students have to form groups or not.
We will arrange the project such that you can form groups. So typically you can either work all alone or in pairs. And if you work on a project as pair, then you will have to build a bigger project. Not all projects, well, we haven't finalized all projects yet. Not all projects will be able to work in groups. But if there's a chance for us to arrange a project such that you can work in pairs, we will allow that to have you work in pairs on a thing. But no, you don't have to form groups. You can work all alone at your leisure. Debugging is something that is best made alone anyway.
Okay, then there is again the question whether there is a final exam.
No,
the answer to this question is no.
Exam. I am expecting your projects, and I'm expecting your projects with a full description.
Then there's a question whether students can participate in this lecture if they pass generating software tests.
Of course you can. Why not? Generating software tests and this automated debugging course, they are completely disjoint, so there is no reason why one should eclipse the other.
Then there is another question: when the students have to register in the LSF?
I actually don't know about the LSF. That's not directly one of my concerns. But I can tell you that. There's typically there typically is a period of 2 weeks where we have to choose which courses to take, and I would very much encourage you to register in LSF within the next 2 weeks.
Then there's a question on how the grading is done, whether this is graded by hand and by looking at the code, or whether we automate this, like in programming too, with public and hidden tests.
That very much depends on the specifics of the project. If there is a chance for us to do this automatically, namely because we expect something super specific from you, then we will do this automatically. So we will run your debugger against a set of benchmarks. However, there will also be exercises where creativity is asked. So For the first thing, for instance, interactive debugger, you can design your own user interface. And this is something, well, user interfaces is something that will actually be checked by Hans and I, that is by us.
Okay, then another question, will there be a detailed guideline for the expectations of the projects?
Yeah, that is a question that goes directly to you, Konstantin and Johannes. Will there be a detailed guideline on the expectations of the project?
So yeah, we will pretty much make sure that you know what you have to do and what we expect from you. This should be clear from reading the project description what you have to do. And if there are any questions, there is also the forum where you can ask them. So if something is not clear from the project description, just ask in the forum. We will answer that question, make sure that you know what to do and what exactly to do.
Mm-hmm. I also have the chat window open right now, and I could have a glimpse at it right now. What is the duration of each project? When are the deadlines? Duration of each project will be between 3 and 4 weeks. So we have, I think we have 12 weeks overall and 4 projects. So that's on average 3 weeks per project.
Okay. I think there is one last question, whether there will be office hours or tutorials beside the lecture.
We do have, we don't have specific office hours, and in particular, this meeting on Tuesday is the place where you can ask questions, plenty of questions about the material that we just had, as well as the material that follows. And so this actually serves as a huge office hour, if you wish. But we also do have a forum, and if you go to the CMS, if you go to cms.cispa.saarland, if you go to our webpage to the very beginning, you have a menu here which is called forum, and in the forum, let me just click on that forum because I can. In that forum, you will find a forum for automated debugging, and in automated debugging, you already do have specific threads for technical questions, general discussions. Oh, there's no posts yet, so actually it might be a thing for you. Might be a thing for you to start things in here. So here we go, and we're back in automated debugging. Sounds of happy Cuba dances. You haven't seen the project yet. Okay. What else do we have? Any other questions?
Yeah, there's one question whether we are following any specific framework in Python.
Are we following a specific framework in Python? No. We are building our own framework in Python, namely debugging frameworks. And we are starting with, and we are building up one building block after another in order to build great debugging techniques.
There was just another question. If someone is medium good in Python, how much time will the projects actually need realistically? And will it be like programming 2, or will it be more difficult?
I consider myself a sort of average programmer in Python, I guess, and typically one of these projects should take me about 3 to 4 days to complete on my own, that is, but then I'm an expert too, so maybe a couple of days more. I have no idea what the reference point is, but rest assured, if something takes too long, if something takes too long for everybody, we can easily adjust things. But generally speaking, these projects indeed will be a bit demanding. On the other hand, each of these projects is going to result in something that a professional programmer in another language would take years to build, years altogether. And and with every single project that you build in there, you can so much impress your friends. This will be amazing. You can tell, and then you will say, I built this automated repair thingy for Python. And then people say, you did what? And then you can put this into your CVs and everything. This could be pretty cool, actually.
Okay, so there are another 2 questions, maybe 3. So the first question is whether students have to have good UI design experience for the projects.
Well, if you can build great UIs, that certainly is going to give you a couple of bonus points if you have a great choice of colors and whatnot. But this is not the primary. Evaluation scale. We'll mostly look into functionality, that things work as they should. Also, only the first project out of the 4 will actually have a small user interface. The others will be tools that should be able to work fully automatically.
Another question is whether the project will be similar to extensions to an IDE, like ReSharper, for example.
No, your projects will all be standalone and will work in Python for Python without IDE integration. IDE integration again is something, yeah, we can do that, but then again, you will have to study and debug your debuggers for days and days just to understand how the specific interaction with the IDE will be, and that's something I would very much like to avoid in this course.
Then there is a question whether there will be an introduction to UI programming, because there are people that don't have any experience with that.
Yeah, the UIs in Python the very little, as I said, there's not much in UI. The very little thing we're doing here is you build a very small web page with HTML, which should be part of your capabilities, or actually it's not very difficult to learn. And what you have to do is to attach a bit of JavaScript to the individual UI elements. Even so, the UI is an optional part. So even in the first project, you can do this either as a pair with some UI programming, or you can do this alone, and then the UI is perfectly mandatory, and the code for command line debugging, this is all provided to you.
Okay, then there is one more question regarding the deadline for the final project, namely when the deadline for the final project will be.
This is going to be a couple of weeks after the last lecture. So when is the last lecture? I guess mid-February. We're going to
beginning of February.
We're going to announce this, and we'll be liberal on this.
Okay, so I don't see any more questions right now, but maybe so that we don't miss any questions, it would be best if you ask your questions in the Q&A section. Yeah, so that doesn't pop up in the chat, but it pops up in the Q&A, and we can say that the question was answered. When you do this, we won't miss your questions. And there is the first question. Is content of material enough for the projects, or do we need to follow external material?
Wonderful. This brings me directly to my next point. Let me get you into the material that we provide. And in order to cut things short, the answer is we provide everything to you. That's a good answer. What you need is a web browser. And I'm going to point you to a particular site. This is the site where I am compiling the material, and this is beta.debugging.org. So let me just type that in for you so that you can see things. Beta.debugging.org. You can actually go to that site right now if you have nothing else to do. So, oh, I don't even share my screen. I do. Okay, let me share my screen here such that you actually see things. Here we go. Okay, one more time. You type in beta.debugging.org in the browser of your choice. And then you end up on this wonderful site, which is called the Debugging Book. And this is actually the place where I am assembling all the material for you. This is indeed going to be a book of sorts at some point, not necessarily so much a printed book. It actually is far more fun to read this, and in particular to interact with this on the screen. And this is where I will be assembling material as we speak. So you can go up to the top level menu up here, and here's the chapters that are already in there. Well, it looks like 5, but in fact it's 3. And this is, for instance, where you can then find your topic for the next week, which is Introduction to Debug. Oops, why didn't this work? Oh, come on, this is a bummer. What happened here? Oh, yes, sure. Yeah, I've been to the wrong page here. So here we go, Introduction to Debugging. So let me see when this works. Introduction to Debugging. Yes, here we go. You have to start with beta.debugging.org. Otherwise, you're going to end up in pages that are not there. The beta.debugging.org. The beta is the secret handshake. This is only for you. Only you know that this beta thingy exists. Everybody else won't see anything. And in this introduction to debugging, this is one of the chapters. This is the chapter we're going to look through right now. And you will see there's plenty of material to be read and examples and pictures and whatnot. So this is what we go through. And just because I said that, building a debugger in Python is a very simple thing, let me go to one chapter later, where we actually have, where I'm actually showing. Where is that? Oh yes, there we go. Yes, this is a debugger in Python. This is 3 lines of code. And these 3 lines of code, for instance, give you access to the current line number, the current function that's executed, all the variables at your disposition, which you can then happily print out. And you can actually, you can access these variables, you can toy with them, you can do all sorts of stuff. And doing such a thing in any other language, accessing the variables as we speak, is so much work. And in Python, this is just a matter of seconds building things up. There's also a menu up here where you can actually go through the individual subsections of the individual chapters. And the most interesting part, however, is that these chapters, as you see them here, and as they come with text and Python code, whatever, these actually all are so-called Jupyter notebooks. If you go to resources and then look at edit as notebook, what you're going to find in there is, this doesn't work anymore, too bad. What you're going to get is an environment where you see the same material as in the chapter, except that this is an interactive environment, which means that you can actually go and change things as you like. This is lots of fun, and this opens for lots of very interesting consequences. In particular, you can run all your experiments as you like. And for this, you have a couple of choices. You can either edit this right in your browser. You can try this out right now if you wish, and then you should be able to see this right away. But you can also go and download the code to your hard disk, to your computer. You can also download the notebook on your computer and then work with it by yourself. Oops, it has just downloaded the whole thing. And you can also download archives with all code that is there and all notebooks that are there. So there's a couple of opportunities for you. And but your main working environment should be the notebook. And this is what such a new notebook looks like. I have now opened the first chapter in my Jupyter notebook. And here you see the very same text as I already have it here. So this is Introduction to Debugging, and here's an introduction text. And this is the same material, except that in my Jupyter notebook, I can actually edit things. So I can go and edit this text. Well, that's interesting if I want to write a book. But I can also edit these code section. All I need to do is I can click on these, and then I can edit things as I like. Well, that's a very simple thing. And then I can even execute them, and I can try them out as I like. And this is also the same environment that you will be able to use for your project, which means that you can actually experiment with all the code and try out the individual examples, try out what's happening in there, find out what the individual parts are doing. That's one thing. And you can, and you can also use the very same environment to actually build your projects and to build your own extensions to the material that is around. So a couple of things of questions. So do we have new questions, Johannes, or shall I just continue?
Yeah, there was one more question, whether the criteria of how we judge the submissions will be made clear in the project requirements, but this is the last question there was.
Yes.
I mean, again, we will make sure that you know what you have to do, and we will judge the projects according to what we want you to do. So it should be clear how we judge the submissions. Yeah.
Okay. So for the rest of today's lecture, I'm going to give you a short teaser on the material that you are supposed to process for next week. We're going to go through, we're going to have a single example. And this is one example that is going to follow us for quite some time, because it's an example where one can illustrate a number of debugging techniques, manual debugging as well as automated techniques. And that's assuming that you now have the chapter actually opened up in your Jupyter environment. As I said, you can be in here and then you go to resources and edit as notebook, and then it will automatically open this wonderful binder environment, and then it will launch the server automatically for you. This normally takes about 1 minute, and then you can edit things right in your browser. I'm going to use Jupyter Notebooks as I already have it open on my machine in order to save a bit of time. What we're going to do in our example function is, the idea is that we are going to remove HTML markup. HTML, I assume that most of you already have seen HTML source code at some point, or at least know the basics of it. It's not very complicated. It's not very complicated. This is a text that comes in, so this is a bit of text that comes in HTML. And you have this HTML markup, which comes with these special markup tags, for instance, in order to make sure that some text is emphasized, as in here. And then this will, a text like this in HTML will be rendered like this in your browser. So this is emphasized, and you can see that emphasized over here is actually shown, well, in an emphasized way. Interestingly enough, you can actually do your own HTML experiments, because you can actually look up the source code of this whole thingy, and you can actually enter your own tags to this just to see how they look like. So if you want to experiment with HTML, this is what, say, the strong element does, and this is just regular emphasis. So we go back again. So normally we're not going to edit these text parts. This is this is already a given. But what I want to build today is a function that actually goes and takes away these HTML tags. That is, it takes an HTML input, such as this one, and then it converts this into regular text without any particular markup or anything. Maybe useful if you want to pipe an HTML page into a text editor. And our idea is to write a simple Python function, which does precisely that. So Python, Python. Python is a language that is, well, that is that is a bit special. If you have been programming in Java or a language like C before, the first thing you will notice is there are no types. That Python is a dynamically typed language. That is, a function like this, like remove HTML markup, which takes an argument s. Well, you can pass in any s that you like, although the name s may suggest a string, which it is. There is no static type checking. Types are being checked dynamically, meaning that if something goes wrong, you will notice at runtime. We also have a couple of types, but you have a couple of types in here. You have Boolean values. So I'm having a Boolean variable, which is named tag, and I'm having a string variable, which is named out. And if you just find that this is underlined here, that's because we don't use these yet. Another interesting thing about Python is that there are no braces. So in other languages, you may have braces like these, and well, maybe something like that at the end. And oops, all of a sudden, this looks like C or C++. There is nothing like that in Python either. Instead, Python structures your code by indentation, meaning that any code that is indented in here under this definition keyword actually belongs to the definition of a function. And if something is outdented, so if I write something like x equals 442, Then this is outdented. This is no longer indented as in here. This is an assignment to a global variable at this point, whereas if I indent it, then this becomes part of the function definition. So, but still, this is a function, and you have seen functions. There's nothing special about a function in here. So I'm going to build this function which removes this HTML markup. And the first thing we're going to do is I'm going to build a loop. So this is a loop, and this iterates over all elements in S, which is a string, and the iteration variable is C, that is a character that is for every character in that string. JavaScript has a similar thing. There you also can iterate over elements of a list. I think in C++ it's possible to iterate over lists. Otherwise, if you program in Java, does Java have iterations over lists? That's an interesting. Yeah, in Java, I think in Java it's named for each or something. That's a common thing. So now I'm having something, I'm going through all of this. What I want to do is I want to go through over all the characters in that string. And now I want to check whether something is maybe the beginning of a markup, something like that. If C equals an opening angle, and you see this is all very common as well. This is just the same keywords as in other languages. So you have if, you have equals as in C, and here I have a comparison against. This looks like a character. In fact, it's not. I can also write it like this. Then Python has no specific notations for characters. Everything is a string, and strings can be enclosed both in double and single quotes. Sometimes it's useful. This can be useful if I want to check, for instance, if something is a quote, I can write it like this. Or I can also check for a single quote, and I can enclose the string in double quotes instead. An interesting thing happens if a string is enclosed. If a string has both single and double quotes, then well, I have to go through extra tricks. But we are simply going to go and check for a single character here. In all generality, in this book, I'm using single quotes when something is when a string is internal, and I'm using double quotes if a string actually is end user facing, and this string is not end user facing, so I'm using single quotes. So what we're doing here is if we are finding an open angle, then we set the variable tag to true. Otherwise, if we find a closing angle, here we go, wonderful, then we set tag to false again. And now the fun part comes. Oops, false, thank you very much. Where is auto-completion if you need it? And the interesting thing is that otherwise I'm going to add the, out is out plus C. I'm going to add the character to our out variable, but only if tag is not set. This means that if I encounter an opening angle up here, I'm going to set tag, and then everything will be ignored until I find the end of the angle, and then tag is false, and then characters will be added again. So this is a very simple way of writing out. I can also use a typical C-like compression here. I can write out plus equals C, and then this simply means that that character string C will be appended to out. So this is it, but I can also do this in a very simple way, and then it will be super readable. There we go. And then in the end, once I've done that, I do return out. And I think I'm done at this point. Do we still have anything that is, why is this thing underlined? I have no idea. Interesting question. What happens here? Invalid syntax. What did it? Oh, yes. Oh, sorry about that. That's actually something where somebody in a live audience can raise their hands and say, why Professor Zoller are you putting two ifs in here? But fortunately, I have my own electronic stuff here, which helps me out with that. So this is now my function remove HTML markup. And now comes the fun part. In a Jupyter Notebook, I can press Shift and return to automatically execute whatever is in here. And then it will be executed right away. If I do any mistake in here in this code, for instance, by having another if in here, there we go, boom, then I'm going to get syntax errors, invalid syntax, and I can fix things right away. So here we go. Apparently our function is syntactically correct, which actually also means that now I do have this function defined. And I can actually now invoke it, and I can see what happens if I invoke it with, say, a string like foo, and I get the result right away. So I'm typing in. This is a bit like a read eval print command line loop, and I can enter commands as I will, except that I always see what I have entered before, and I also see the results of things right away, and they stay within my document. I can save the whole thing, and everything stays in here. So this is the remove HTML markup of foo, and that's not very exciting because this string actually does not contain any HTML markup. And I can now add some HTML markup. So let's make this emphasized whatsoever. Boom. Here we go. And this also works. Wonderful. Yeah, cool. Ha. I am the coolest person on earth because I just managed to write a small little Python program. So as you see, there's really nothing, there's not too much exciting about there. You have if, you have else ifs, you have comparisons, you have booleans, you have string operations. Yes, and behold, numerical operations like, say, additions or floating point numbers whatsoever. They all very much behave as you know them already from other languages. But I can now also go and I can also go and say I want to check whether this is correct or not, and then I say, okay, I'm having this function in here, and it should return true. Or and then I can go if should this by any chance not return foo, then I'm going to what can I do? Can I raise an error? Can I raise an error? That's a good question. Yeah, possibly. Well, I don't know yet. I have to make a mistake in here first. That raise error or name error is not defined. Too bad. Well, but actually that's for a good reason, because this remove HTML markup of thingies. Oops, here we go. I'm going to copy this all here. I'm going to add this down here. Now no longer returns foo because it adds an X character all the way. So you can easily simulate things as we like. Okay, good. So we have a function for removing HTML markup, and we're done. So great. This was your exercise for the day. Thank you very much. I'm sorry, we're not there yet, because as everybody knows who's ever been doing some HTML, who's ever worked with HTML, HTML tags do not simply consist out of angle brackets and identifiers like these, but there are also more complex. More complex tags. In particular, a tag can take arbitrary attributes. For instance, if I want to write a link to foo.com, that would be interesting. I have no idea what's behind foo.com. So let's make this debuggingbook.org before we infringe somebody's copyright. Then this also works. We're still good. Everything is fine. That's all perfect. Wonderful. The problem is, however, that these things here that actually come as arguments, they can also take less than and greater signs. So what happens if I do this, for instance? Exciting question. So I think this is going to work just fine. Is it? Yes, it works just fine. Everything is automatically removed. But here comes the fun part. What do I do here? If I have such a quoted character in my HTML tag, and note, the HTML tag goes from here to here. Okay, so this character here is actually not part of the HTML tag. However, our remove HTML function here doesn't know this. So what happens is that the single quote here, which we have here at the very end, is all of a sudden included because our remove HTML markup function has no idea about quotes. Okay, so we're stuck. Our function doesn't work as it should, and this is a bad thing. So now we have to go and actually fix it. Well, there's a couple of ways to fix it. A very simple way to fix this is, well, we can just fix what we see, and we can come up with a very simple fix to thingies. So we can say if s equals this string, return foo, boom, fixed, huh? See, that's a very simple way to fix things. This is of course this is of course this is of course not a preferred way to fix things, but this is actually a technique which some programmers apparently use to patch their code such that it passes all the tests. And yes, this is going to work just beautifully. There's even examples of banking code where, well, not so smart programmers have managed to work around some issues and whatever. Yep, this is a typical problem of a fix that only fixes the symptom and not the cause. That's one problem, but doesn't really work well. Another technique which you can do is so-called printf debugging. Printf debugging means we are going to insert lots and lots of print statements into our function. So, and there's also a print statement in Python, and it's super popular. It can take anything. So here already comes the automatic guide for what you can do during printing. So I can say I want to print s, for instance. If I do print s, then the string is automatically going to be printed out to my console. And print takes everything. This is called printf debugging because in C there's a function called printf which has the same function. So it takes a format on top of it, But you can now go and just say, okay, I'm going to look into whatever happens here. What is my S? What is my C? And I can look out through the individual characters, yes, and how they're being added. And I can add another one and another one. So let's do this here. So I can print out just because I can. Oops. So bops. And then you're going to clutter your output with plenty of extra statements. Yes, you can do that and figure out what's going on, but we already know what's going on. Well, our remove HTML markup function has actually no provision for quotes whatsoever. Okay, and so what are we going to do with this? What are we going to do with this in this chapter? So what we're going to do here is we're going to go and take this array function. Here it is again. Let's make this a bit bigger for you so that you actually can see things. Here we go. By the way, this hash character here is the beginning of a comment. This is like shell comments, for instance. Here we go for the standard stuff. Here we go for the interaction stuff. That's what we have just seen. And here comes a typical example of how things work badly. And what we'll be going through in this chapter is, first, we're going to introduce a somewhat more abstract notation for what's going on in our code. Namely, we're going to look into a finite state model that actually shows what is happening in here. So we start with things, and then we have a character that is not an angle, we add it, and then we are in the status of not tag, we go into the status of tag. And what we do not have here is anything that actually checks for these things. We can now add another state, which is quoting things or not quoting things. And then we can make sure that if we are in a quoting state, then tag characters will actually be ignored until we come to the end of the quoting. And then we end up with this extended remove HTML markup, which accepts these smaller signs and greater signs only if quote is not set, and quote is set whenever, or actually quote is toggled whenever we see one of these greater or one of these double or single quotes. And now this works, but there's other things which do not work, and we now continue with various iterations through the entire program. We also build up a bit of theory, how the failures come to be from defects to failure. And this is then how we can then systematically process the bug and systematically use a method called the scientific method to systematically find out what's going on. The scientific method, I'm going to spend another couple of minutes on that because this is a very important thing to know whenever you're manually debugging, and I really don't want you to miss this thing. The thing is, this is a very simple diagram of the scientific method. Scientific method is actually a method by which you can come to scientific findings very systematically, not only in debugging, but actually anywhere in nature. You start with some observation in nature. Why does this apple fall down, for instance? And then you wonder, why is that? And you come up with something that is called a hypothesis. You come up with a possible cause for what you just observed. In debugging, this can be a problem report. This can be code, this can be runs, or this can be more runs. All of these influence your hypothesis. And from this hypothesis, you build what is called a prediction. That is, you say, okay, if my hypothesis holds, then the following must happen too. And then you have made a prediction. And this prediction is then something that you verify in an experiment. And from this experiment, you get then more observations that tell you whether your hypothesis is supported, and then you refine it, or whether your hypothesis is rejected, and then you come up with another alternative. So what could possibly be wrong with our function right now? Oh, it doesn't handle quotes. So I'm going to make a prediction. We need to handle quotes in a particular way. Then I make an experiment by handling quotes in a correct way. I make an observation. Quotes are now handled correctly. So let me check whether this actually holds further. Or I didn't implement this correctly. Then I need to seek an alternative. Okay. And this allows you to treat bugs as if they were natural phenomena, and you can systematically narrow down one part of the input after the other. And we also have a couple of quizzes in here which allow you to check whether things are correct or not. So let me just try out. So, oh, this was by pure chance. How could I possibly do that? Okay, good. Just ignore what I just typed, and I'm not going to tell you what's the right answer. And here we go through a number of extra steps in order to further refine our function. And in the very, very end, after going through all the quizzes and everything that we have seen, we actually come up with a version of our function that actually works. Okay, all of this coming up with a number of experiments and going through the individual steps is actually something that is similar to the game of Mastermind. Mastermind is a game for two persons. You have one person who's sitting here at the end and who's coming up with a secret color combination. And you have another person sitting in front who's trying to guess that combination. And for every input, in here, the player whose pins are hidden provides some feedback on the number of pins which have the correct color, and possibly also the correct position with these white pins and red pins. And from this feedback, our mastermind, that is the player who needs to figure out the secret combination, comes up with more and more attempts, comes up with more and more experiments and more hypotheses on where the individual pins could be, until all the pins at the very end and until all the pins are in their correct position. And of course, every new experiment must be consistent with all the earlier observations. If you look at this, there's also something else which is important for debugging, namely that you want to make your individual hypotheses and your results explicit, such that you can look them up. Such that you can find out what you have tried out before and what the result was. This is actually also where Jupyter notebooks come in very handy, because they actually allow you to track everything that you've done before. And by making these things explicit, this makes you a better debugger, because you don't have to keep everything in memory. You can always look down on what your previous results were. Making things explicit also gets us to our second big technique in the manual debugging, and this is called rubber ducking. If you've never heard of rubber ducking, that's a technique which is fairly simple. If you have a bug and you have a problem for which you don't have the cause, you should go and try verbalizing it. That is, explaining it to someone. And this someone can even be an inanimate object, such as a rubber duck. if you explain a problem to a person or even to an object, you will be forced to rethink your hypotheses and try them and think about them again and making them explicit, making your process of reasoning explicit. And this helps a lot for debugging. When I was a student, there frequently were other students coming to me and asking me, Andreas, I'm having this particular, this also happened to me as a student tutor and later on. Andreas, I'm having this particular problem over here. I am feeding this gobbledygook into this bubble notch, but I'm using bubble notch version 2.0. But whenever I'm feeding this bubble notch in an invariant state, and it gets into an invariant state because I've checked this, and then this invariant state. Actually, now that I think about it, I have not checked whether this is an invariant state. Let me first, Andreas, let me first check whether this actually is an invariant state, because it may actually not be one. Yes, it actually may not be one. That's true. Thank you very much, Andreas. And I was just there, and I didn't understand a thing, and I was just there, nodding and smiling. I was taking the role of the rubber duck here, and I knew that in about 2/3 to 3/4 of all cases, people would come up with a solution by themselves, simply telling things to me. And but there were plenty of people coming to me, and every time, simply by sitting there and nodding and not understanding a single thing, I would be able to fix their bugs. And this is how I became a professor where debugging would be one of the specialties. Well, I'm your rubber duck. Of course, it's not very efficient to have a full-fledged professional just listening to your whatever debugging stories. So actually, it's a very good practice to first take a rubber duck or whatever object and telling this to the rubber duck first. I happen to have a Coke bottle here on my desk, and I could actually go and explain to my Coke bottle why my computer keeps on crashing. This could be very interesting. Maybe the bottle is going to help. Doesn't matter as long as I explain all the steps I've taken. Okay, oops, and we also have a short section on the history of debugging here, and also just for the fun of it, there's the word bug, which we commonly assume is something that creeps into our programs and then causes our programs to fail. This is a very nice yet misleading picture, because it is not bugs that cause our programs to fail, or, well, it is not bugs that come from the outside. We have created these bugs. It's still us programmers who are responsible. But here's a picture that should actually be in every single book, on every single course on debugging. This is from Grace Hopper on the Harvard Mark II machine in 1947. This is the first actual case of a bug being found in a computer. This was a moth that was stuck in a relay and therefore caused a computer malfunction. And you can actually see here, this is the first actual case of a bug being found. This is how the engineers at the time logged it in their notebooks. Which actually brings us to the point that the term bug is much, much older than computing by itself. Already Edison talked about bugs. And if you look further earlier, you will even find bugs in the sense of a nightmare, or something that is not under your control and threatens you. You will even find references to bugs in Shakespeare's work. This is how old bugs are, and this is how old debugging is. Okay, with that, I think I have gotten you some. I've gotten you some material to read for the next week. This is mostly just for you to getting acquainted with the field, or say, and mostly also with its terms, with manual debugging. In the week after, that is next week, we will go into actual programming, namely into tracing executions. And this is where we will then actually build our first debugging infrastructure, which now goes through individual parts of the function now with tracers and logging functions. And that actually these are actually a number of techniques that allow you to to have the program to log the execution and show specific events and everything. But this is something we're only going to see in the week after. So with that, this is my preview on the chapter. This is my preview on the chapter of next week. So what do we have here? I'm looking into the chat window here again. We already have people answering ourselves. That's so cool. We have sounds of a crying C++ programmer. Oh yeah, okay, I can get that. I've been programming. I've been programming debuggers in C++ actually too. There's a program. There's a debugger called GNU DDD, which is mostly my code, which is well, a big contraption these days, but used to be a very popular debugger at some point. And I think that I've given you enough material for the next week to read and to go through, and some motivation too. So I'm happy to take further questions. Johannes, what does our chat window say?
So the chat window doesn't say much, but the question and answer windows has one question.
Please.
How many chapters do we have, and how much time is recommended to be spent per chapter?
That very much depends. So the first chapter on debugging, this is going to be this is rather long, but it shouldn't be more than 1, at most 2 hours. The later chapters take more time because in the later chapters there will be code, and this code will be more complex than the remove HTML function, which I have just sketched. So it may take you a bit more time to actually understand what the code is doing and how it is doing that, and therefore you will not only be reading what's in the chapter, but you will also be very much encouraged to actually try out things by yourself. So, but this is just for you to get. But for you, your homework for next week is to read this very first chapter on Introduction to Debugging and getting acquainted with the environment, that is getting acquainted with Python, with Jupyter notebooks, such that you are able to try out all of these examples by yourself.
Okay. So far there are no more questions in the Q&A window.
Okay. And I see you're already answering yourself. I should point out that interesting thing, important. If you go to the chat window and you type an answer in there, the answer only goes to the panelist by default. So we have answers here. The link is available on the main page. That is nice, but the attendees are not going to see that. Okay. So if you have if you as attendees already have an answer, then you need to make sure that this actually also goes to all attendees. And I'm not even sure whether you can type questions into all attendees. The link to the book, because this has been asked a number of times, is actually available on cms.cispa.saarland, on cms.saarland/debug. This is where you can find all the links to the Zoom window as well as to the book, all the chapters, all the resources you need, and I'm happy for any feedback that you may have. Okay. I think we're out of questions at this point. So I'm looking forward to see you again next week on Tuesday, where we will be going through tracing executions and checking out how to actually observe the execution of programs and what to do with that. The week after that, we will build an interactive command line debugger for Python, which is also not too complicated yet. And this will then also be the base of your first project. So in 2 weeks, we will have sufficient material altogether such that you can start with your first automated debugger. Okay, Konstantin, Johannes, anything from your side still? Monitoring things?
No, there are no more questions.
Okay. All fine. So for any other questions, just use our forum, and we'll be happy to answer.
Okay, then thank you very much. It's been a pleasure, and see all of you next week. Bye-bye.